Good afternoon, everyone. My name is Pan Xiangling. I'm a student from Eastern China Normal University. Today, our topic is to compare the difference of academic immersions with different cultural and language backgrounds based on a case study for Chinese and English MOOC platform. Thanks to the information technology, we can take courses online. We will feel that education becomes more equal, and we can participate in different courses we are interested in. Back to our childhood, we always dream of attending course without going to school, which has come true nowadays. And due to this pandemic, it seems that online learning will replace the face-to-face learning. But is online learning really as good as we think? As we can see, in face-to-face learning, students make progress. The teachers will directly pursue the feedback from students. They are communicating effectively and efficiently. But in online learning, the interaction between teachers and students is not as direct and effective as traditional face-to-face situations, which blocks the emotional interaction between teachers and students. If the teacher can't see the student's facial expression, just speak to the computer. The teacher doesn't know the student's reaction and feedback, which leads to obstacles in the adjustment of teaching strategies based on academic emotions. Research shows that culture affects emotional expression. Students of different cultures have different ways to deal with emotions. Learners will have cultural differences in emotion analysis. MOOC is a learning platform for learners with a large number of different cultural backgrounds. This requires platform developers and course developers to provide support for students from different cultural backgrounds. What is the emotional response for students in a multicultural background? This is what we are interested in. Based on this background and the data we can obtain, this research is based on big data and artificial intelligence methods to compare the difference in the expression of academic emotions between students of China and English-speaking countries in the MOOC platform. This research obtained 100,000 student comments from Chinese mainstream MOOC platform and Coursera. The data on the Chinese MOOC platform was obtained through Canvas, and the data on Coursera was obtained from Kaggle. Because the Chinese machine learning training model was used, so we translated English comments on Coursera through Google Translation. The Google Translation has a high accuracy rate, so we ignore the interference caused by translation. After data cleaning, the two platforms each get 58,999 data. The sentiment analysis adopts the deep learning academic emotion classification and aspect classification method proposed by Feng Xiang in 2020. The first dimension is the aspect of comment. The second dimension is the academic emotion of comment. Chi-square tests are used in these two dimensions respectively. The first dimension is the aspect of comments. The aspect contains three categories. There are comments about teacher, platform, and courses. The second dimension is the academic emotion expressed in the comments, including enjoyment, hope, joy, relaxation, anger, shame, anxiety, disappointment, boredom, This method integrates sentiment analysis based on convolutional network and attention mechanism into an aspect-oriented academic emotion analysis pipeline architecture. After each comment is analyzed by the pipeline, the aspect and emotion category corresponding to the comment are output, and the accuracy rates are 88% and 71%, respectively. The aspect frequency is shown in the figure. The chi-square test is used for the aspect under the Chinese and English platform. In the test, the value from the Chinese platform is used as the observation value, and the value from the English platform is used as the expected value. There is a significant difference in the distribution of aspects. Chi-square equals 2,350 in the evaluation of teachers and courses, and the contributions to chi-square are 48% and 50%, respectively. The frequency of academic emotions is shown in the figure. The analysis of academic emotion data under the Chinese and English platforms show that the frequency of hope, joy, relaxation, shame, boredom is very small, so they are not included in the chi-square test. Finally, we tested enjoyment, anger, anxiety, and disappointment. In the test, the value from the Chinese platform is used as the observation value, and the value from the English platform is used as the expected value. There is a significant difference in the distribution. Chi-square equals 319, and the evaluation of anxiety and anger in the contribution to chi-square are 35% and 46%, respectively. Based on the use of the chi-square test, the study found that there are significant differences in the distribution of student comments in terms of aspects in academic emotional expression. As for the aspect of comments, there is a difference in the distribution of students' evaluations for teachers and courses. As for the academic emotion of comments, there is a difference in the distribution of anxiety and anger among different cultural students. This conclusion can provide guidance for development and optimization of MOOC courses in different cultural and language backgrounds. There are some limitations in our research. First is the limitation of data. Currently, we are unable to obtain the regional of different students on the platform. So it's impossible to associate each common data with the cultural background, and we ignore the differences in the course on different platforms. We hope that in the future, the platform can open more data for deep research on the relationship between cultural background and academic emotions. The second is the accuracy of artificial intelligence classification algorithms. The sentiment analysis algorithm for the education field lacks an effective dataset, and it lacks extensive research. The algorithm used in the article has a classification accuracy of less than 90% on aspect and academic emotions. In the future, we will continue to optimize datasets and algorithms to increase the credibility of research results. These are our references. and thanks for listening.